Hi all. Today I'm going to explain about NPTEL week 4 assignment with solutions. Okay, I'm not going to brief about the theory questions answers. I'm going to brief only about the problems what they have given in NPTEL week 4 machine learning assignments and the problem solutions also. Okay, so here is our first question. They asked about the storage requirement of a breadth first search algorithm, the concept. Okay, for that, what is the storage requirement? They are saying this right answer is O plus N plus N. Okay, that is for a breadth first search algorithm. If it is depth first search algorithm, then the answer will be S plus P, or else we can say that answer will be P plus N. Okay, so mostly for depth first search, the answer will be P plus N, and if it is for version space search, then the answer will be S plus G. Okay, only 3 answers will be there. Okay, and the next one is, this is the question which they have given for the next 3 questions depends on the same data. Okay, there are 3 instances: instance 1, instance 2 and instance 3. The upcoming 3 questions are depending only on this instance. Okay, so we have to look into this and we have to do the remaining 3 sums. Okay, so this is just an instance based data. What we need to do is the first instance we need to take. Okay, what is our first instance here? Angry, a black horse and happy, a brown cow. That is our first positive instance. From that we have to do 3 for the depth first search. We have to take 3. What is this one? Current best hypothesis. From the current best hypothesis case 1, we are taking the first positive. From that we are going to derive the second step as well as the third step. As in the question they have asked only the third step, so we have to follow what we will get in the third CBH3. Okay, so what is our first one? First one is about angry black horse. Okay, so in that angry black horse we have taken the same, and then the first word angry, the remaining 2 we made questions, and these 2 made questions. After that we are making angry as question, which is we don't know, and then the remaining black horse we have taken down, and that is the answer for this question for depth first search. The same things is just a shortcut. I'm not briefing you what is whether it's right answer or not. Even for the breadth first search, for that also the same answer is going to be. Okay, and here you can clearly see that they have given 1 mark for those answer. And the last one is here the version space approach. Here in the version space approach we have to take the first positive instance, and then the thing is here we have the S1 as well as we have the G1, specialization as well as generalization. In that we have to look into the same what we have given in the breadth first search, depth first search. The same thing we will follow here. For the G1 only we will make 3 question marks, and then the last G3 will be the first 1 question mark, and the second word we have to consider. And then here from the second instance, see from the first instance, the third word we have to consider. If you follow that one, definitely you will get right answer for this question also. Okay, and then we are going for this one ID3 algorithm, that is which is not too rare asked. For that the answer is employs a dynamic programming policy, and here we have come for the problems. Okay, so here what they have asked, the question is entropy of decision tree data set with 9 positives and 5 negatives. So this is very important question. In that 9 positive and 5 negative, how we are going to find the entropy means, so here is our formula: minus P of I log 2 log base 2 P of I. This P of I is maybe a positive, so they have given positive as well as negative. So what we have to take the whole formula first, and then we have to take the whole formula next. So when we are doing this P of I, what is this P of I? We can clearly say that our positive instance divided by the overall instance, the positive 9 and negative 5. So we are adding up the both positive 9 and negative 5. So we are taking this one as 14 we will get if we take. Here it is they given only the positive instance, but we have to go for the negative data also. So when we are taking the whole formula, what it comes, minus summation of P of I log 2 P of I minus again my P of I log 2 P of I, it will come. So if we are making bracket together and bring this minus out, we will get plus in between, and then we can get the values of positive separately as well as a negative example separately. Okay, so when we are doing, we will get that values like this, a log base 2 of, it's very important, log base 2. If you are doing it's log 2 with the normal, log 10 with the normal values means we will get other values. So we remember that when it is log 2 base, log base 2. Okay, if we do this one, we will get the answer as 9420. We will take this as our answer. Okay, and the next one, this is just the entropy, and the next question it will be on gain of entropy. So we know that the gain is a combination of positive as well as negative, or else the different two entropies. So if you are going to find about the overall entropy gain, means we have to take the first, the overall, that n, this value we have to take it first here. Entropy, what is the entropy P of this ring? That is nothing but 0.91 minus the summation of here you can clearly see the summation of this the first instance as well as the second data. The first instance, what is our data? 80 divided by the overall gain. So this is our value. Here you can see the overall n. Okay, we are taking that one over here, and then 80 divided by n, and then the first value is the entropy. What is that? 0.34 again. Plus, it is very important, we are taking this one in this, inside this brackets. Okay, this entropy of P is nothing but 0.91 that we have taken directly, and then in bracket we have to consider only these two, then only we can get the overall gain of the value. So 80 divided by 120 into 0.35, again this 40 divided by overall n into 0.95, this value, entropy value. Then we will get our answers as 0. If you multiply, see 80 by 120 is 0.006, and into 0.34, and 40 by 120 is 0.33 into 0.95. When we are doing this, adding this both, we will get 0.54, and minus that one from our overall entropy 0.91, we will get the answer as 0.37. This is the method of doing that overall gain. And then this is our next question, where they are asking about the k nearest neighbor algorithm to find the blue which is nearest to the query instance. Okay, so here there are many rings. The first ring they are taken as number 1, and second ring as 3, and third ring as 5, and fourth ring as 7, and fifth ring as 9. So which ring and what are the rings? The blue is very near to this query, means in the first ring it is near to the query, and then the second one, and then in the third ring it is near, and as well as in the fifth ring it is in the third ring what they have mentioned here is a 5, and then in the fifth ring they have mentioned is 9. So we are marking the answer as 159. So even our answer is being correct in NPTEL. Okay. And then the next question, it is very important question, Manhattan distance. Most probably they will ask this Manhattan distance. What is this Manhattan distance? Means they will give two vectors, the x1 vector and x2 vector. We have to cancel the x1 vector from the y1 vectors, and we have to find the distance, the difference between x vector and then the y vector. Okay, so here one important thing we need to note down is they have given in the modulus. So if the difference is a negative, also we have to consider this as a positive. That is very important point over here. So when we are seeing in this question xi minus yi, so I just made the question as 6, 5, the data is split it up like that, and then if you are making y1 minus x1, okay, so if you minus 5 minus 6, we will get answer value 1. 7 minus 5 minus 7, what we will get? We will get minus 2, but as it is given in the modulus, we shouldn't consider that as a minus 2, we have to consider in positive instance only. So remember that when we are considering in modulus, then we have to consider only that values in a positive. So after taking the values, we have to add those all the values, I mean the differences, then we will get 12. So even my answer is being correct in 12. And then the next question is this one, cosine similarity between x and y. This is very important. Here this what is the formula has been given, which is nothing but summation of xi into yi. Okay, as I do not have the same kind of formula, so I just taken as the xi and y, ai and bi, and here the summation ai square into summation of bi square whole, I mean a square root, and then here b square root. When we are going inside that a square square root. What we need to do means a1 square plus a2 square plus a3 square and so on. Here I have clearly mentioned, sorry, here I have clearly mentioned that one. First on top, 5 into 5, okay, and then 5 into 0, 0 into 5, 5 into 0. If you take that all numerators, we will get this value, and then in denominator we have to square each and every data first. Okay, for x data, this is our x data and this is our y data. First we have to square the x data separately. 5 square, 5 square, as we know 0 square is nothing, 0, and then again 5 square, 5 square, 5 square. So total of 5 5s are there, so making them into, as well as into this yi, okay, y1 square, and then y3 square, y4 square, y5 square, and y7 square. So if we do that one, we will get the data like 75 into root of 125 into 125. So 125 into root 125 is nothing but just 125. So 75 divided by 125, we will get the answer as 0.6. Okay, so that is the right answer. And here is the next question. A two-dimensional array. So in that two-dimensional linear separable input space, they have given two things, so x data as well as z data. We have to consider this here, 6 comma 7, and this is x1 data, and this is 7 is x2 data, and here the 7 is z1 data and this one is z2 data. So which I have taken over here, and the formula, it will be like multiplying x1 and z1 and multiplying x2 and z2, and then adding up then an overall square we have to do. That is very important. Don't miss that. So we will get values like that. And then this question is about string partitioning. As we know, the string comes under clustering technique of grid-based clustering. And this is the last question where they are asking about hierarchical based clustering, where we have to cluster this data. Six rows and 6 columns are there. We have to cluster them, and we have to bring the data into 3 into 3 matrices. Okay, so here if you do the second step, what we need to do is, anyhow this data will become 0 0 0. We have to maintain 0 0 when doing clustering. And here what we need to do is, this 4 data, CD and AB, this 4 data, we have to make it as adding, finding the average of 5 plus 3 plus 3 plus 5 divided by 4. Okay, this overall 4. Again here the same, 7 plus 9 plus 9 plus 7. These 4 values were divided by 4 because the 4 values are there, so dividing by 4, finding the average of those two. And if we do that, when we will get this values like 16 by 4, 32 by 4, 16 by 4, 12 by 4, and 32 by 4, 12 by 4, and 0. Once if we do that, we will get the values as 4 8 4 8 3 3 and 0. So it is very clear. In these options we can say that the last option is being correct. Also I have scored 1 marks. So this is the week 4 assignment solutions along with the formulas. I am not able to explain the formulas very clearly, but I hope this will be somewhat useful for your examination preparation for machine learning topic. Okay, thank you for listening. Thank you so much.